Hi everyone and welcome to Astronomy Talks, a tour of misguided astronomy where we talk about some historical astronomy topics and how we've come to realize that our beliefs were wrong. Thank you for submitting requests for this week's episode. I've gotten a lot of requests to talk to you all about our moon, actually. Our moon has been, up there in the sky as long as us humans have been around, and throughout the years we have been curious about how did it actually get there and what's it made of and stuff like that. So today we're going to talk about the formation of our moon and the different theories that have been brought up over the years about that and where we are today. Alright, so let's just jump right in here. First we're going to talk about one of the earlier theories on the formation of the moon, which is known as the capture hypothesis. This hypothesis is pretty simple in its conception. It basically just says that the moon was formed somewhere else in our solar system, not near Earth. And then during planetary formation, when all the planetesimals were still moving around, what is now the moon was captured by Earth's gravity as it was passing by, and the gravitational interactions between the two bodies resulted in what is now the Earth-Moon system. Over the years we've discovered that the capture hypothesis is feasible. In fact, we know that Neptune's moon Triton is likely a captured moon. It's in a retrograde orbit, and it shares a lot of similarities with Pluto, which means it was likely originally a Kuiper Belt object. So we know it's possible. However, when it comes to our moon, I don't know, we think it's pretty unlikely because as we will find out in the 1960s, when we finally go to the moon, late 1960s, the moon is actually a very similar composition to Earth's mantle, so that means it probably was formed somewhere at least near Earth, so probably not coming from somewhere else in the solar system. So now we know that the moon likely came from somewhere else, but even without knowing that, George Darwin in 1879 theorized that the Earth and the Moon were once a single body during planetary formation. Darwin, the younger and less famous one, his theory became known as the fission theory. And basically what he suggested is that the material that formed the moon was ejected into space by a molten and fast-spinning Earth in the early stages of Earth's formation. He theorized that the equatorial gravitative attraction on Earth was nearly overcome by the centrifugal forces. He visualized that the resonant effects of solar tides adding to this centrifugal force to overcome gravity and would separate a solar tidal bulge into the present moon. Once the moon is separated from Earth, it was likely driven to its current location by a transfer of rotational energy and momentum through the gravitational effects of the Earth's tidal bulges. Darwin was right on track according to many later scientists, but the angular momentum and energy needed to transfer the moon to its current location probably wouldn't produce the current Earth-Moon system. In 1963, though, Donald Wise modified Darwin's hypothesis by adding a possible sequence of shapes taken by the Earth as it goes from a stable spin to an unstable state where the fission can occur, and then back to a stable spin. So at a low spin rate, the proto-Earth likely had a shape very similar to Earth's current shape, a sphere. But as the spin rate increases, the Earth would flatten until its axial diameter was about 7/12 of the equatorial diameter. So essentially just imagine grabbing the Earth and squeezing it at the north and south poles, and the middle squishes out, making like an oval if you look at it from the side. Eventually, when you look at it from the side, it kind of starts to resemble a pear, and the stem end of the pear would separate to become the moon. Once separated, it's able to reform into a sphere under its own gravity, and the Earth will return to a stable rotation, and the tidal forces between the Earth and the moon will drive the moon to its current orbit. So, Wise did his best to solve Darwin's problem with the angular momentum. However, he kind of made another issue because this would likely result in some highly eccentric orbits, but the moon orbits Earth in nearly a perfect circle, so they weren't quite right yet. So it seems like no matter what theory we present here, there's always some kind of issue that makes it just not quite right. So do we even know how the moon was formed? Yeah, I'll get back to you on that after a quick look at our sponsors. This week, our sponsor is the CU Boulder APS department, so big shout out to them for keeping us learning and passionate about astronomy. We really appreciate it. And yeah, back to the moon. All right, so we are getting there. We are almost up to the present as far as the formation of the moon. In the beginning of the 1970s, scientists posed what now is known as the co-accretion theory, which basically states that the Earth and Moon formed separately but from the same accretion disk, which is to say that the Moon formed in a very similar way to how the Earth formed and at a very similar time. We know that in the late stages of planetary formation, there were many protoplanets, and a lot of them collided with proto-Earth to form the Earth that we know today. And co-accretion scientists say that the same thing happened with the Moon. There was proto-moons in orbit of proto-Earth, and through gravitational forces and collisions, we get some larger bodies, such as what would become the Moon. We know that the isotope ratios of oxygen in moon rocks and Earth rocks are identical, so this really reinforces the idea that the Earth and Moon are formed in the same planetary formation zone, or at least at the same distance from the Sun, which is explained in co-accretion. However, if they formed at the same distance from the Sun, they should have similar abundances of iron, and the Moon is actually pretty deficient compared to Earth. The Earth has a very iron-rich core, and the Moon does not. The theory also fails to explain why the Earth-Moon system has such high angular momentum as compared to other systems in the solar system. So while it's good in the sense that, yes, they were likely formed at a similar distance from the Sun, there's still a lot of issues with this theory. So just a few years later, in 1975, Doctors William Hartmann and Donald Davis published what their hypothesis was on the formation of the Moon. This is known as the giant impact hypothesis. So basically, they claimed that at the end of planetary formation, 4.5 billion years ago, an object the size of Mars collided with Earth in a giant impact that ejected lots of the iron-deficient crust and upper mantle material from Earth into orbit in a cloud of dust. All these particles would interact gravitationally and through collisions, and then they would collapse the cloud into a disk and coalesce to form the Moon. This is very similar to different ideas on how solar systems and planets form, so it makes sense. And you might be asking, does this solve the angular momentum problem? We keep bringing up like, oh, the angular momentum, and we think it does. You see, if you have an impactor as large as Mars and it hits the Earth off center, as they hypothesized, it would have sent Earth into a rapid spin, which would help conserve the angular momentum from the ejected material. The next problem is, how did the material ejected become to be traveling fast enough to get into orbit? And the thought is that on top of these gravitational forces that are present, there would also be pressure gradients in the vapor that was likely produced, and that would help accelerate material away from proto-Earth. This also explains why the giant impact hypothesis, that is, explains why Earth has such an iron-rich core and the Moon doesn't, because in this theory, the Moon is only formed from material in Earth's crust and mantle, and by this time of planetary formation, the iron would have already gone to the core. So it makes sense, and that's what we think today is the most likely hypothesis for the formation of the Moon. So there you have it. After millions of years of intelligent life being here on Earth and looking up in the sky almost every night, seeing the Moon, we finally figured out how it got there. It took us a while, but we made it. So yeah, I guess that's going to wrap up our episode this week. Just want to say thanks to everyone for tuning in. It's been a real pleasure talking to you guys this week. This has been the one and only episode of Astronomy Talk, so I hope you enjoyed it. And yeah, stay curious. Bye.